The question is, when the head of a military convoy is in line with a pole, a messenger on a motorcycle from the rear moves forward to give a message to the convoy commander who is traveling in the leading vehicle. The length of the convoy is 1 kilometer. By the time the messenger, after giving the message, comes back to join the rear of the convoy, he finds that the last vehicle of the convoy has just crossed the pole. If both the convoy and the messenger were traveling, at constant speeds, how much distance the messenger would have traveled from the time he left the rear of the convoy till he joined that original place? This is a quantitative aptitude question more on proportions rather than on speed, time and distance. Even though he is traveling, it is more on the proportions. You'll have to work it out rather than on speed, time, distance. So what I understand is the military convoy always moves forward. So the convoy is moving forward. The chief will be the motorcycle commander is here, and the motorcycle man is at the end of the convoy. The commander is here. So what happens is it is moving like this. This is going like this. This length will be 1 kilometer. That's what the length of the convoy is 1 kilometer. There will be lots of vehicles in between. Between the commander here and the messenger here, there will be lots of vehicles. They will be forming the entire convoy. And this distance is 1 kilometer. It is moving in this direction. Now, when the commander is exactly in line with the pole, the messenger from the rear starts from here and goes and gives a message to the commander. So, because the convoy is moving like this, the commander would have moved up to this point. I will make this point as X. So, what happens is, when the messenger would have traveled from here till this point to give a message to the leading commander. So, what happens is, the commander is here, he is moving in this direction. The messenger will have to move faster than the entire convoy to give here. What they say is, the convoy and the messenger traveling at constant speeds means, see, the convoy is moving at 30, the messenger will have to leave at 40, otherwise he can't go and meet the leading commander. And he is maintaining the 40th road. When he returns also, he is maintaining the same 40th road. So what happens is, when the commander has moved X, actually this is moving, it's totally moving like this. Suddenly he starts moving faster and going to give a message to the commander. When the commander is moving X, the messenger will be moving 1 plus X. When the commander is moving X, the messenger will start from here, he will be moving 1 plus X. Now, the convoy is moving forward like this. The convoy is continuing his journey like this, and he returns back. The messenger returns back from this point to this point. When he returns back, what he says is, he comes to join the rear of the end. The last vehicle of the convoy has just crossed the pole. So what happens is, when he is returning back, he will be exactly at the pole. When he returns back from this point to this point, he will be exactly at the pole. This is where the catch point of the question is. When he is exactly at the pole means, the messenger has moved from this point to this point. The messenger has totally moved from this point to this point. So he has totally covered. 1 means the entire convoy also should have moved 1. Now when the commander was here, commander would have moved 1. So the distance, if this is 1, the distance the commander has covered from this point will be 1 minus X. So when the commander is moving X, the messenger is moving 1 plus X. Either called as a commander or a convoy, whatever it is, because the commander is also moving 1 kilometer. So what happens, the commander is moving X, the messenger would have moved 1 plus X. When the commander is moving 1 minus X, this is the distance he is running, or this is moving, the messenger returns back from this point to this point will be X, but what I do is, I will convert this, and this is when the commander is moving X, this fellow is moving 1 plus X. So when the commander is moving 1 minus X, messenger will move 1 plus X divided by X into 1 minus X. And this is the distance that is coming back. He will come back this distance, which will be equal to X. Now solving this, 1 minus X square will be equal to X square. or 2x square will be equal to 1, x will be equal to root of 1 by 2. Now the question is, what is the distance travelled from the time I left from the near the corner till I joined? So he is travelling this point 1 plus x plus x. So he will be totally travelling 1 plus x plus x. So which will be equal to 1 plus 2x. This will be equal to 1 plus 2 root 1 by 2, which will be equal to 1 plus root 2. So this is, if this fellow is moving x, it is 1 plus x. Same proportion of 1 minus x, this divided by this into this. You can call it a chain rule or a cross multiplication, whatever it is. But that proportion distance will be moving. Subscribe to my channel. I will be adding questions every now and then.